Okay, it's a definite integral, and I sort of appreciate that because it allows me to, just switch all the way from one variable to another variable. Before I do that, though, I want to point out that x squared minus 1 must be greater than or equal to 0. And what does that mean? Let's just make sure to understand that between, let's put this over here. And I'm going to say plus or minus 1. One certainly is okay. Minus 1 certainly okay. And I'm kind of curious, like, what happens after 1? Is it okay there? It is. So I know it's over here somewhere. So I know it's certainly, the limits of integration are fine for this. All right, let me get my eraser out. I don't go beyond that. And I'll make a substitution. And what's this going to make is a trig substitution. And that's going to be x equals the secant of theta, which means dx. The derivative of secant is going to be secant theta, tan theta, d theta. I can certainly do that much. All right, let's write that down. I'll put the limits down later. So what do you get? You get secant squared theta minus 1 got that covered. What's dx? It's secant theta, tan theta, all right, now let's do the limits of integration, see if that gets any better. And let's write it down for you. So if x is 1, it's the lower limit, that would mean the secant of theta. Whoops. Certainly on the invertible region that we're talking about here. And where would that occur at 0? That's pretty simple. Let's do the upper limit, which is 2. And that's a secant of theta. Now, I'm a fan of rewriting these guys so they're more familiar to me. Like I say, the cosine of theta is a half. And when is cosine of theta equal to half? That would be what angle? That would be, let's see, 1/2. That would be 60 degrees, right? And 6 degrees is pi over 3. All right, so I went from the land of x's to the land of thetas now. And let's see if this integration simplifies. And I'm going to say 0 to pi over 3. Secant squared theta minus 1 is going to be the tangent squared theta. And between 0 and pi over 3, we got a positive tangent, so don't have to worry about that. So what do you get? You get secant theta. That's coming from this guy here. And then I got 2 tangents, which means there's tangent squared. All right? Yeah, you start to say, what am I going to do with that? And I don't know. I guess maybe rewrite the tangent in terms of secants now. I'm going to start to get my eraser out, though, and I'll tell you the reason why is that I'm moving away from the old into something might be a simpler integration here. But if this doesn't get simpler over time, I would just drop it and try something different. But anyway, let's keep going. 0 to pi over 3. Secant theta. And the tangent squared theta is going to be secant squared theta minus 1 d theta. Well, deja vu all over again, isn't it? What's it going to be equal to? 0 to pi over 3 secant cubed Okay, I want to remind you that we've done both of these integrations prior. So we've done this one prior, and we've done this one prior over here. Now, if this is an exam question, I would certainly hope that I'd have to not keep repeating things over and over again. I would just go back over my exam paper, and I would look for the answer of the secant cube that I've already done already. All right, we've done that one already. And that one turned out to be this guy over here. And we also did this one. We did them both. Now I got to make an evaluation, don't I? And let's see if we can do that. And I'm going to get my eraser out now. I'm going to start looking at my notes. And I want to point out where we are. We're right here. And yeah, I know it's a lot of work. And I got to do it. And one thing nice about it is, the pi over 3, I want to write this down for you, is a rather easy angle to deal with. I'm kind of glad for that. I'm going to put this over here for you. It's going to be the theta, and that's going to be 2, 1, root 3. And I certainly want to know, for example, the secant of theta would be 2, and the tangent of theta is just a root of 3. All right, it's pretty easy to write down. Let's do that. I'm going to do the upper limit. And what do you get there? Let's take a look. You're going to get 2 root 3. I just did that. And then you're going to get this over here. And that's going to be, let's see, the natural log. And it's going to be secant, which is 2, plus, that's going to be 2 plus root 3. Over 2 minus, what I'm going to do is write this as natural log of 2 plus root 3. I'm going to pull that together. Well, let me do the lower limit now. The lower limit's 0. That's the upper limit. When is the lower limit, which is 0. So I can do that. Well, let me get 0. And let's see, the natural log, that would be, we're doing 0, right? Secant of 0 is 1, tan of 0 is 0. Boy, that's 0. Isn't that convenient? Let's pull it together. 2 root 3 minus the natural log 2 plus root 3. Let's get the red pen out, see how we did. We're good to go to the next question. Thank you.